So we're back here again today, and I want to go over another training video. So today I want to go over training on the calibration of the YSI 6 series sonde. Usually we use a YSI 68020 to do our continuous monitoring, and a YSI 6920 to do our discrete monitoring. Both probes are calibrated the same and can be calibrated together, which is great. It saves time and we can accomplish more in a shorter period of time. So what I want to go over today is actually just calibration of the YSI 6 series sonde, the 6920, which we're currently using for everything, which is more productive. So what I want to do is I want to go over how to use this sonde and what calibration solutions we're going to need to calibrate it, and also what equipment we're going to need. Okay, so let's go over the rest of the equipment here, the important stuff. Okay, so in front of me is all the solutions that we use to calibrate. We have some cleaning solutions, and then all the actual solutions, and then actually rinse solutions, so we can use the spent solutions to rinse out the calibration cup. Okay, so let's go ahead, and then actually you can then to the right of that, then we have our calibration cup right there, and then we have air to blow out the joints and clean out some of the ports, and then DI water behind the air, and then we have our 6920 probe. And then over to the right we have our YSI data logger 650. So that should do it for all the equipment we need, and as long as we have our maintenance log, our USGS maintenance log to record everything. All right, let's go over each the solutions really quick. Okay. So starting first, let's go ahead and work on our proper documentation. So to start out, this is our USGS water quality meter calibration maintenance log. So this is where we record all of our data for each probe, but we're actually just working with the 6920, so we'll just work with the YSI 6920 today. Okay, so let's go ahead and look at what we put in here. So I will put in anything at the beginning that has to do with the maintenance of the probe, major maintenance that gets sent off to YSI headquarters or any other maintenance facility, probe replacement or sensor replacement, seal anything that is requiring larger maintenance not in-house. Okay, so let's go here to one of the most current, the last one for say. Okay, so this was done last year. This is a partial calibration, so let's go to a full calibration. Okay, so here's a good example of a lot of notes. So let's start out on the left side here. So what we're going to do is we start out by putting in the name, or the name of the probe. Let's see if we can get that. Okay, station name and number. So I just put in basically the name of the probe. I put in the date and my name, and then so the major sections we're going to be using here was not using temperature. We can use temperature, but we have to have a NIST certified thermometer, and that can be done once a year. And then so the main ones we're going to be doing are specific conductivity, dissolved oxygen, pH, and turbidity. So let's start off with specific conductivity. So basically we're going to start off with the standard value, which is usually 1,000 micrometers per centimeter cubed. Hard to see, but but when we're actually in the I'll show you in the data logger, it's a little different. Okay, so then we do the lot number, which I'll show you where it is on the specific conductivity, and then the expiration date, and then the temperature of the standard before it's calibrated, and the initial reading, and then the final reading, which should be the same as this, but sometimes it comes out at millisiemens per cubic centimeters. So but it's just a factor of 1,000, metric. So And yeah, so that's great. I mean, you can put in other information, sensor ID, but it's not really super important for the weekly. Okay, and then below that, we're going to dissolved oxygen, and we go ahead and calculate with water, saturated air, which is very simple actually. It basically includes putting about an inch or two of water just in the bottom of the cup without the water actually touching the sensor. And then, so what we'll do is record the barometric pressure, the temperature, and then 100% saturation from the chart, which is actually 87%, and then the initial reading. And then the adjusted reading, which is the final. So initial reading and then after adjusted. So it might actually be more like 86.6, but it's basically about that. And then the other thing we want to do for this is wiper replacement. So if the wiper is kind of going out, we want to make sure we note that if we replaced it or not. Okay, and so then we're going on to pH calibration. And so pH calibration, we actually have we use two solutions, a 7 and a 10. We can start off with a 7 and then finish with a 10, so we can have a 2-point calibration just to make sure it's in point. And then we put in the lot number, which is on each bottle, expiration date for each buffer, the initial buffer temperature, and that's where it's important to get that initial temperature, because that initial temperature will actually change the initial pH. And so if the temperature is, say, 16 degrees Celsius, then there is a buffer corrected temperature, which is on the side of the bottle. Okay? And then the final pH, which should be the same. So this might actually, the adjusted might actually be 7.04 or 10.07, you know, something just slightly different. And which in that case, then the adjusted pH would actually be 7.04 or 10.07. And then we can put in our millivolts, but it's not super important. The two should align correctly. And then, okay, so then we go down to turbidity here. And turbidity is the last sensor. So there's just a total of 4. And turbidity is also done with 2 solutions. It's done with DI water and this YSI 6074. So DI water just has a standard value of 0. It needs to make sure it's deionized water, because otherwise can have particles in it. Sometimes I guess you could use reverse osmosis water and stuff, but it's better to use DI because it's completely pure. So just make sure you put the standard value and the lot number in for the YSI solution, and then the expiration date for the YSI solution, because as far as I know, I don't think that there's an expiration date for DI water. And then the initial reading, which is going to be interesting, because sometimes the DI water acts up because it's so pure, and the turbidity sensor is kind of touchy when it comes to really small numbers. So the best way to do this is actually to calculate DI water first at 0, and then get a reading and you zero it out, and then you go back. So this would be, and then you go back and do a YSI 6074 at 1,000, yada yada yada, expiration. Then you put in, then you get your initial value, and then you finalize with should be about 1,000, and then you actually go back again with the DI water, and you do 0.8 and not 0, because if you do 0, what will happen is actually go negative, and you don't want that. See, because this is already negative here, and so you're actually recalculating it above 0 to try to keep a negative from happening. But I've actually done this in the sense that later on I've actually just skipped the first calculation and just did a 2-point calculation, and just started with the solution and then finished with DI water at 0.8, and it seems to work fine. So I would recommend just doing a 2-point calculation, start with the YSI solution, and then finish with DI at 0.8. And then finally, the last thing is this is also has a wiper, and you want to make sure that this gets replaced every so often. So, and if you do replace it, make sure you document it. Okay, and then over here onto the right side, so the first thing I like to do is I use tap water as a good reference to see how much it changed. And so I take an initial reading of tap water, and then after calibration I go back and take a final reading, and that way I can kind of see if there's a big difference, and if so, then where the difference is, and if there's a sensor that might be out, or so on and so forth. Then I make sure to document all that. And then below that I take any notes if there's been any issues or any changes, so I take notes on the changes here or issues with the calculation. And then any other changes down the line, any other issues, just make sure to document them. So that should do it for the USGS calibration and maintenance log. Okay, so in order to go over the solutions, let's go back to this maintenance log here, and let's look at the order that we first started in. Okay, so let's start with conductivity. Start with the conductivity solution. Alright, so these guys are the conductivity solutions. So one of them is going to say rinse, and one of them is going to be not expired. So the rinse is always going to be the expired or spent solution that you just want to use to rinse it out, to clean out the cup and get it, you know, thinking along the lines of that solution. And then, so here we have on this calibration, or on this solution here, if I can get it to focus. Let's see. Okay. So, let's see if we can get it to go. Okay, so what we have is the item number, which we don't need, and you can see at the top YSI 3167 conductivity calibration. So we need that, and then we need the lot number, this guy right here, the lot number, and then we need the date used by, which is basically the expiration date. And other than that, that should be good. So some of them are temperature appropriate, but this is not a temperature based solution, and it should be fine. So yeah, so that's the calibration solution, and then you just make sure you rinse out two times before you before you actually calibrate. So all right, so next let's go back over to the book here, okay, and the next one down is dissolved oxygen. So dissolved oxygen is great. You just put tap water in the bottom and you put in about 2 inches. So we'll go over that in a sec. Then let's go to pH. So we have 2 pH. So the blue is actually the 7. Pretty sure. Nope, 10. Okay, well the blue is 10 and the yellow is 7. Okay, it's the same thing here. We have a blue, which is which is our our 10 pH solution, which is YSI 3823, and that is a lot number at the bottom, 19H1T. And then we have our rinse. So just make sure you rinse once to twice before. And for pH, so there's different volumes you need to put in each, and so the deepest, the one that you have to put the most solution in for, is the conductivity. That needs to be over the top of each, but we'll go over that in a sec. So that's, and then actually the other thing you got to remember about pH is it's actually temperature dependent. So if the temperature is different, the actual pH is going to be different. So you wouldn't calibrate it to 10, you'd calibrate it to 10.06 or 10.12. So you just got to keep that in mind for pH. So, and then this is our pH 7 here. So pH 7, YSI 3822. And same thing, it's temperature calibrated, and the lot number is right down there. Okay. And then, okay, so let's go back over to here. And so our last one is turbidity. So let's go back to turbidity here. Our turbidity solutions. And so actually there's a bunch of different turbidity solutions, but we started out with like 1,000, but since our turbidity is actually pretty low, we switched to a 12.7 NTU turbidity solution, and that is the YSI 6136, or YSI 6072. Sorry, that's it. Yeah. So yeah, but this will work for both the EXO and the 6 series Sondes. So this will work great. It's a lot of solution, but it seems to expire quicker than you can actually use it unless you have 2 or 3 Sondes. Okay, so then we want to work with the lot number and the expiration date, and make sure we document the date opened when it is opened. So great. And yeah, other than that, the turbidity is pretty straightforward, and then I just keep on hand a small bottle with the turbidity rinse. So just a rinse with this beforehand, just to make sure to clean it and prep it for that, rinse it for turbidity itself. So, and that does it for all the solutions for calibration, other than alcohol for cleaning, if you want to clean the joints and stuff, and then also for DI water, just for cleaning the joints as well. But then to look at it really quick, we do have some other pieces in here, an extra pen, plugs if we want to clean out, clean the sensors. We can remove the sensors and cover the probe cover, the sensor cover the sensor port. Same thing for a different size. We've got gloves, industrial paper towels for cleaning, and yeah, and then other brushes, which there's more brushes to clean if you need it, and a scrubby pad. So clean in between the ports and a few extra port pieces. So yeah, that should do it. On to the next piece. Okay, so let's go ahead and clean this baby up. All right. So what we want to do is we want to scrub around the ends, and then we want to go ahead and scrub around the edges, and if we can, in between the scrubby pad, scrub around here, and then we'll take this guy off, and we'll go ahead and scrub around here as well, and then on the inside of this actual connector right here. So cool. Okay, so let's finish with our cleaning here. Let's go ahead and turn on some just room temperature water, and we'll just run this around, just cleaning that port, clean on the top, clean out on the base, anywhere that you see any like buildup of like a brownish temp color. Just try to get it all off, clean off the edges, and just try to get in between it as much as you can. But be careful, because some of these ports are super sensitive and they can easily break. So actually, I think this long one is actually pH. Now that I think about it, because the pH probe is really skinny and it's got that bulb at the end. So yeah, I think that's the pH, and it's really sensitive. It's easy to break, so I just gotta be careful. See, it's even flexing right now, and I'm barely moving it. So yeah, just clean all that you can, and you need to take the scrub brush and put it in between. A little bit in there. As clean as you can, and then finally just get in with these threads with a toothbrush and just make sure the threads are clean. It'll make life a lot easier. You gotta make sure they're all cleaned out like that. So yeah, so should be good, just like that. And so yeah, that should be done thoroughly every time you get calibrated. So that does it for the cleaning. Okay, so let's start off with this port here. Let's go ahead and take this off. Okay, so let's go ahead and spray this off. And we'll go ahead and use the toothbrush and scrub all the way around it. Get off any debris and dirt we can. And make that joint as clean as possible. Same thing with inside. So sometimes you can use alcohol. Like I can smell the rubbing alcohol in there, but unfortunately, see, this is an issue. If it's not cleaned correctly, see the color right there? It's hard to see it, but there's a little bit of color in there, which is actually corrosion. We don't want that, because if it's going to corrode, it might actually start to go haywire and whatnot. So I'm going to have to get in there with a brush and try to get that off right now. So, can't seem to focus on it, but that color, yeah, right there, that greenish color at the bottom. So, yeah, we're going to need to clean that. And that's where alcohol helps, because it's a quick dry kind of thing, but it's really important to make sure these joints are clean, because it's super important. Alright, let's go ahead and get there with a brush. And that's definitely not going to fit. Alright, so this is where it gets to be a pain, is trying to get in there and actually be able to clean that off. So what we don't want is we don't want that corrosion connecting the pins. if it connects it, it can malfunction and whatnot. I'm not sure exactly how to get in that because I don't have a brush that's long enough in there and narrow enough. But it looks like that toothbrush is getting in there, so it's just got to work with what you got and just be creative. So it looks like it did get it. I don't see any color at the bottom down there now, as long as the pins aren't bent. So, yep. Alright, that looks good. So that's good. And then let's go ahead and move on to the other cable. This one's a little harder to get out, but just get that toothbrush in there. Or you can hear the stuff in the bottom of it. Sand and whatnot. Blow it out in the little port. Blow it out as much air as possible. So on and so forth. Alright, so that should be good, and then you can kind of tell if it's working, it's clean when you go to put it back on and it goes on. It'll bind up further down, but it shouldn't bind up at the beginning. Should get most of the way down, and then what I just like teeter-totter it back and forth. And it seems to work pretty good, but you gotta just be careful. You can't drop it while you're trying to tighten it. See, it's not all the way on. There should be like maybe one, maybe at the most 2 threads, but right there that's 4. So I just have to keep going as far as you can, but it's a pain. So, all right. Alright, so here I have the Sonde tools little box with different adapters in it. Inside here wow, look at that. There's the actual. Okay, I couldn't find it. I don't know why. Alright, well, it's there. So it's in the same box. And then these are the new guys. So we're just gonna basically take one, cut it in half, and put half on each side. Let's go ahead and do that. I think first off we're going to need scissors. Let me go grab those. Alright, so let's go ahead and try to put this on. So what I did was I just went ahead and basically grabbed the scissors. I cut it in half. And then let's go ahead and put this on. It's kind of tricky, but okay, so this actually the dip is going to go down. So what you want to do is you want to put this in on one side. You actually put it up a little higher and hold it, and then slide it down so it's about even. Okay, and then you just bring it up on the other side and slide it in. So, and just make sure it's all the way in there. And you can give it a little slack in there. You don't want it super snug on the bottom because you want it to drag. So what you do is just bring it down a little bit so it sticks out. But just be careful not to rip it, which I did, but it'll be fine. Just be alright. So yeah, that's it. And then what you're going to do is grab your Allen wrench. Don't lose the Allen wrench. It seems tiny. And then you're going to look for a flat spot on the tip here. You're going to look for a flat spot right in here, and that's where the set screw is going to go. So line up the set screw with the flat spot. Make sure it's pressed down. You don't have to press it down hard, but it should be down most of the way. And then go ahead and toss that in there. Get it in there and then tighten it up, but just make sure that set screw is on that flat spot so it'll hold better. And tighten it up. And then you're good to go, and then that'll work great. So, cool, and that should be done every few months. If it's worse, change it sooner. That last one was a little dirty, but I couldn't find the set screw, so I wasn't able to replace it that soon. So I just had to wait. But yeah, it was still okay. It was reading fine, but good to replace it when you can. Thanks. Okay, so let's take our cup here. Let's go ahead and we'll get our first initial calibration set up, or our initial reading of tap water. So you can put it down and just make sure that our water is covering that one sensor, the short sensor where that hole is on the side. Make sure it's covering that, and basically the top of all the probes, sensors. So, okay, and just be careful where you put it because it can fall off. You don't want to catch the cable or whatnot. Alright, so let's go over here to the data logger and let's go ahead and look at that for the first time. So, okay. So let's go ahead and see what we got here. The data logger is kind of annoying, but it does a good job. It's pretty simple when it comes to calibration. Okay, so we got our calibration book, blank book, and we have our data logger. So the first thing we're going to do is we're just going to go ahead and run it on tap water, and then we'll let it sit for a minute or two, and then we'll go ahead and get our initial tap water reading, and then we'll do the same thing at the end and just see how much it's changed. But yeah, so we got our ports in. So let's go ahead and set up our while it's reading, let's go ahead and set up our book here. Okay, so let's check this out here. Okay, so let's go ahead and put the station number or probe. So let's go ahead and 6920, and today is the 26th, 21. Ryan. Okay, and then we'll start off with on the right, and so we'll just put in tap water, and then we'll just do initial and final. So just leave enough space on the left to put in the probes. Okay, so we'll start off with pH, conductivity, specific conductivity, salinity, temp, DO, and turbidity. Those are the main ones we can measure, and then we just get an initial reading, and then we'll move on to calibration. So I think we'll be pretty good here. I wait a few minutes and just make sure that the pH has stabilized. The DO might fluctuate a little bit, and usually it's going to change every time I calibrate. The DO does change a little bit. So okay, so let's go ahead and get an initial reading. Okay, so our pH 6.96. Conductivity is actually below specific conductivity, so as you can see here, so that's conductivity is right below specific conductivity. It's always right below, and it's a little bit less. So I think actually now that the temperature is higher, it's pretty close. Okay, so conductivity is 0.140, and specific conductivity is 0.147. So our salinity is 0.07. Temperature is 22.65. DO is 5.36. And then finally our turbidity is 7.9. So we can just leave it running for a sec. Actually, we can go back on the probe at this point. Now we got everything. We can go ahead and escape. Press escape. And then now we're back at the home menu. So we're going to menu. And then we're going to go to calibrate. Second one down. And then we're going to go ahead and start off. And so our first one is specific conductivity. So let's go ahead and jump into conductivity, specific conductivity, and let's wait. And then let's go ahead and fill up our conductivity. So we'll do that. Alright, so let's dump this guy out, and we'll go ahead and rinse with the conductivity solution. I think 2 rinses is pretty adequate, so just put in an inch or 2, screw it all the way on, shake it out, dump it, and then do one more. Just make sure it's the rinse, because this stuff gets expensive. And make sure it's, yeah, there's always a lot of conductivity rinse. There's actually 2 in here because you use a lot of conductivity. So dump it once more. We'll dump it once more, and then let's go ahead and, okay, and then let's go ahead and fill this guy. Remember, this has to go really high because this is the main, it's the shortest probe. And let's go ahead, make sure it's all the way over that little hole, and then let's go ahead and back over to our meter and go ahead and press enter on specific conductivity. And then it's actually 1 because it's under millipascals, or millisiemens, not microsiemens. So press 1, let it run and just let it stabilize. Okay, let's go back over to our book, and then what we'll do is we'll go ahead and put in the main numbers we need here. So what we need is a standard value, which is actually 1,000. And then what we need is the lot number. So we need 2 zeros. Okay, and then we need an expiration date, which is the use by date. So 9/30/21. And then we need a standard temperature, which, so we're going to go ahead and put in 26 because that's what the meter says. And then our initial reading, let's go ahead and look over here. And so our initial reading is actually really close. So our initial reading is actually, so this is specific conductivity on top, is actually 1.001. So that's great. So it's actually not out of calibration. That's why I recommend doing this every 6 weeks or so, because sometimes there's nothing, it's just not out of calibration. And now I just put 1. So that actually does it. Or in this case, it's 1,000 because, you know, it's based around microsiemens. It's annoying, but that's how it works. Okay, so let's go on to the next one. Okay, so let's go on to the next one here. Let's go ahead and jump back on the book here. So next in line we have dissolved oxygen. So this one's actually kind of easy. So what we're going to do is, like we were talking about, is we go on to water saturated air, which is just basically a little bit of water at the bottom. Cool, let's go ahead and do that. So I actually don't want it touching any of the probes. So just keep water in there, but just make sure it doesn't touch. So that's pretty close, but it's actually not touching, it's just touching the wipers. So just leave that, and then we don't actually have to seal it. We don't actually have to screw on the threads, so just leave that unthreaded. Set it over there, and then let's go back over to our data logger. Let's go ahead and go back to our normal, our last one. Go escape out of the last calibration, and then let's go down to pressure or dissolved oxygen at the bottom. Okay, and so this one we want to actually just do DO saturated %. And so we just do 1 point. And so this is actually our barometric pressure. So let's write this down, 661.3. Okay, so 661.3. And then press enter. And we'll wait for it to start up, and then we get a temperature. So let's toss our temperature in there, 23.29. And then from our saturation chart, we just looked at the last one. I think it's actually 86.6. And that's what it keeps. So that's just from the chart. But it actually, you don't actually have to press that in. It automatically calibrates that based on the barometric pressure. So at this point, once it's kind of stabilized, give it a minute or two, and then just go ahead and press enter. But you want to read what the percentage is beforehand. And so in this case, it actually didn't change much. It went down a little bit. So I think, so yeah. So what we're left with is 87, which is what we want. So we're actually doing percentage wise. So we can do milligrams per liter, or we can just do percent. It's the same thing. So actually it is 87 for this 100% saturation. So it's 87%. And in this case we did actually replace the wiper, so we need to make sure and select yes for the wiper. And then reading in 0, we don't actually need to fill that out. So just leave that alone. Alright, so let's go ahead and, since we didn't actually use any solution, we don't really have to wash it out because it's just water. So the next one, let's go on to pH, and let's go ahead and rinse it out with the pH solution and go ahead and calibrate for pH. Okay, so let's go ahead and keep going here with the calibration of the pH. So what we got here is we have 2 pH solutions we need to use, 7 and 10. Okay, so let's go ahead and put in 10. And let's go ahead and pull out all these solutions here. We can leave the rinse solutions by the probe, and let's go ahead and put these in. Okay, so let's just get the lot numbers. We actually don't need the number of the YSI type. So for 7, we got 19H2S. We got for this one, for 10, 19H1T. Okay, for 7, let's go for expiration. And expiration usually at the bottom right here. So 8, 14, 14, 21, and 8, 7. Okay. So now the temperature is the challenging part. So what we have to actually do is you actually kind of have to like start to calibrate it, and then like because when you start to calibrate it, then you actually get a temperature. So let's go ahead, and what we'll do is here we'll swap out. We rinse it out. So let's go ahead and rinse solution. We'll start with the 7. So let's get going here. Alright, so, okay, so we'll just put it a little bit in there, fill it up a little bit, and then we'll screw it on, shake it up, and let's do once more. Alright. Alright, and let's go ahead and switch over to the pH probe. And remember, the pH probe is the really long one. So that one shouldn't require a ton, but still need to make sure it's covered. So let's go ahead and grab our actual solution here. Get it up high enough, which finishes off the jar. So, alright, so let's go ahead and toss this in here. If it doesn't make it, then you can go ahead and screw this one on. So you can see it's completely over the probe. See? Alright, fully submerged. Alright, so let's go back over here. Let's look at here. Okay, so let's go back here. So when we're back at the calibration screen, you can read it. So you go down to pH, on the third one down, pH, 2-point calibration. Okay, so this is 7. But let's just use 7 so that we can get the temperature. And once we get the temperature, we can go back and recalibrate. And both of them should be about the same temperature, considering they've just been sitting in the same space. So, okay, so 25, which is great because we don't need to change it. As long as it's about 25, I think it's like 23 and up. Let's see. Yeah, well, basically about 22 and up. You don't need to change it. It's the same. If it's anything else, just check the back of the bottle, you know, and you can adjust appropriately, and then you can go back and change it and put it back. So let's go put it. So buffer temp is 25, and then buffer corrected. You just cancel it out actually, just because you don't need it. So initial pH. Wow, that's great. 7.01. Well, this is very effective This is very effective. I hadn't even calibrated it. We'll press enter and it'll go to 7. Great. Wow, that was really useful. Alrighty, well, let's go on to the next one. Okay, and the second one is just 10. So let's press 10. Alright, so let's go ahead. And now that this is good solution, so what we can do is we'll put it back in the rinse. Pour it into the rinse one. Fill that baby up for next time. Alright, so let's... Alright, so you don't need to go crazy with rinsing with tap water, but you need to do some good rinsing with the pH solution. So one, two, finishes it off. Sometimes it is a little bit extra, but it ensures that there is, and I mean, like this one, it wasn't certain, you don't have to be crazy about extra rinsing because maybe it doesn't need it, because it's pretty, anyway, but it does help, it is pretty close, but you need to make sure it's clean, because if it has the wrong pH solution in it, then it's not going to calibrate to the right pH. So, alright, so it's not a ton, but it's enough. So, which then keeps the pH down. Alright, so just looking at it right there, it's already at 10.05. Let it stabilize for a sec, but we'll put in 10.05. Enter. What do we got? Back to 10. Alright. And that's good for pH calibration. Okay, so let's jump on to the last one. Here, let's go down to turbidity here. The fourth one down. Press enter, and let's just go ahead and do 2 point. We'll start off with the YSI solution, and then we'll go up to the next one, which is just DI water. Okay, so the first one is this YSI 6072, and yeah, and so that's a standard of 12.7. So sorry, that's standard of 12.7. So let's put that in. All right. So the calibration type is YSI 6072. Standard value is 12.7. The lot number is 21C21080021. The expiration is 3/22. And then I'll go ahead and put a date on that because I did open that in March, and that's important to have an expiration. So let's go back in here and we'll toss in 12.7. Shoot. Way up. That's the issue here we ran into. Well, so we're going to go ahead and do a 1 point calculation first. We'll do 2 1 point, and then we'll try this out. Like I said, you can do a 1 point calculation at 0 with DI water, and then do a 2 point calculation. But your best bet is to actually do a 2 point calculation with 0 first, and then the YSI solution, and then go back and do a 1 point calculation with DI water at 0.8. And then that will give you a little bit higher number so that it won't go negative on you, because that will happen. So just looking at this right away, so we have this running, and we did put in 12.7. So let's go back over here to our probe, and okay, so let's go ahead and rinse it. We need to make sure we get our turbidity rinse solution. And we'll do two times here as well. Careful of the cord. Alright, so just 2 times. Alright, so 2 times. So, alright. And then let's go ahead and fill this up. Oh, so it hasn't, actually it's brand new. So now we can put that date on there. Forgot I hadn't used it yet. So we can put our date and put our date on the bottle right there as today to make sure that we know it just opened today. Alright, so let's go and toss this in here. It doesn't need to be sealed as long as the sensor is in there. So, alright, so let's go back over to our book and our data logger. And so if we just look down at the turbidity right there, we're actually at 12.9. Everything is really good. It didn't actually need calibration, but I thought it would be worth trying, and then film this. So that's why I say about 6 weeks, given the water conditions here on Oak Creek. So we're about 13, so let's go and press enter. So 13.1 is initial. Okay, so 13.1, and then we'll go 12.7. But it is important to go ahead and do this 0.8 calibration, because it will go negative on. Well, let's go ahead and let's go ahead and check it and see where it goes with the DI water. So let's press enter again, and we'll go back to one more 1 point calibration. We'll let it, and this time we'll point 0.8. So enter again, and let's go ahead and clean this out. Go ahead and save it. Go ahead and save this for later. One more rinse solution, and then I'm gonna rinse this out real quick. Let's go ahead and rinse twice. This is really important because the DI water is so clean. You know, if you don't rinse with DI water, then you're leaving behind residue and contaminants, which I think it's still pretty hard to get this thing super clean, but it'll be pretty good. But with a little extra water, a few extra rinses is always good. This always helps. Alright, let's rinse this out again. Alright, one more rinse. Alright, and let's go ahead and fill her up. Same thing, I'm pretty sure this is one at the bottom, because that's turbidity. So as long as it's over that one of the black probes at the bottom, turbidity probe should be fine. Alright, so let's go ahead and check out our turbidity. And as you can see, it's about 0.4, which is good, but recommended by YSI, a 0.8 reading would be better, because if it's too close, it will still go negative. So let's go ahead and put, so DI, standard value is 0.8, nothing, and no expiration date. And so the initial reading is 0.4, and then we'll go ahead and press enter, and we'll have 0.8. So, alright. And that does it. That should do it for all the calibration. The only thing we need to go back to is our tap water. So let's go ahead and do that. Let's go ahead and rinse it out, and then we'll put tap water in the cup. Okay, so we'll go back to the main menu, and we'll go back to run. And once it's up and running, let's let it sit for a second, stabilize again, and then we'll go ahead and do our final check. Now the temperature might have changed a little bit, but other than that, I don't think most of it should have changed, because it's the same water coming out of the same pipes. So, yeah, let's just go ahead and give it a sec, and we'll record it down. Okay, so let's go ahead and take our final tap water reading.
So we'll get that final reading so we can compare the differences. So it's all the same thing. Just make sure it's rinsed off, and then we fill up the tap water to actually a little higher, maybe 75%, because we need to cover every probe. So we fill it up to 75%, and then we just make sure you don't have to screw it on. Just make sure it's covering the port on the really short one up to there, and then let it sit for a minute or two. Let it stabilize, and then take your final readings for the same parameters, and you'll be good to go. And then make any notes, any differences and any changes made. Just make any notes on the notes page, and make sure to put this in the AWQDS on the Water Quality Manager computer, so that it is stored digitally, so it can be referenced, and you don't have to refer to the book when you're wondering when the calibration was done and what issues came up or what didn't. Make sure the notes are done correctly. So, all right, thanks. So once everything's done, once the measurements are taken, then all you're going to do is just fill up a little bit of water in the calibration cup, screw it back on, and disconnect it if need be, but then take it back out to site and reconnect it. But it should be good to go. As long as the cleaning and the wipers are replaced and all the calibrations are done correctly, then be good to go. And all the notes are done. So thanks. That was calibrating the YSI 6 series Sonde.